Hello, this is the Bite Weasel, and in this video, I'll be guiding you through how I would make a brand new Roblox Tycoon game from scratch. This is going to be the first episode in what I hope to be a continuing series, where we constantly improve the game and add additional features as we go. I'll be doing my best to explain not just what to do, but also how and why stuff is working the way it does. Once we get into the scripting, you'll hear me discuss my approach, as well as alternatives that you could use, and why you might want to pick one versus the other. It'll be up to you to decide if you want to follow along directly, or just pick and choose from the techniques and features that you learn and combine them together into your own, much more customized game. I hope you enjoy the videos, and let me know in the comments if you have a suggestion on what to add next. So let's get started. The first thing we're going to need is a brand new world, which we can base on one of these templates. The base plate is a pretty good template to use because it's essentially just an empty level, and the only thing it's got in is the spawn point. So this is going to be good for our tycoon because we don't really need much. We just need an area to put our factory. So if you're not familiar with the tycoon sort of game, then you've clearly never played Roblox before because tycoons are so common, they're all over the place. But essentially, whenever a player joins the tycoon, they're assigned a little area of a factory. And then from that sort of factory, they can stand on buttons to build things. Those things somehow generate money, and that money they can use to buy more things by standing on more buttons. So it's pretty straightforward, and that's why I kind of want to start with this as our game. So the first thing that you're going to need for a tycoon game is probably an area to build your factory. So you can do that by adding a single part and then sort of using the scale tool there to sort of make it as big as you want your factory to be. The other way, of course, is you can go down here in the properties and sort of change the size directly. So I think a good size for a factory would be 80 by 80. So a nice big square. But I think one stud is kind of high to stand on. So we'll make it 0.3. And if we move it around, it will sort of anchor it down there to the bottom of the world. Although anchor was the wrong term to use, it will align it with the bottom of the world. And what we want to make sure we do is actually anchor it directly with this anchor thing. So the anchor property will basically stop this from interacting with the physics engine. So if someone stands on it, it won't end up bouncing around. So you'll end up seeing that I use the anchored property quite a bunch because there's not much in this game that I want to interact with physics. So there we go, though. We have a nice factory area that we can start building on. So let's rename this part to be factory so that we know what it is. And let's get into it. The first thing I think we'll need is a button. That's like the main part of the mechanic. You stand on a button and it builds something. And then you need a whole bunch of these buttons. So let's make one. Basically, we can create a new part. We can give it a size. I think 4x4 is fine. Again, we can anchor it to make sure it doesn't bounce around. And this time, I think we will change the color. So we can use something like green. That's a good color. We can change it to smooth plastic, I guess. You can spend a lot more time than I will when you come to do your own sort of tycoon game. But there you go. We have a little button that you can stand on, but let's make it look a little better. We can duplicate this. We can change it to maybe black. And then let's make it a bit bigger. So 4.2 and a lot smaller, like 0.2. We can move that down so it's on the floor there. Now, I think this sort of button now is a bit too big. So we can go here. We can change it to 0.5, I guess. And now we have this button. And in theory, the bottom part is the base plate that won't move, and then this top part is the bit that will move up and down as you sort of stand on the button to show that it's working. So now we have this button here that's essentially made up of two pieces, but we don't want two separate pieces for our button. We want to think of a button as a single like object that we can move around and duplicate and stuff. So the way to do that is to click and select both of these parts, right click then and choose Group as Model. And that model we can rename to Button. So that really gives us a single object that we can use, even though inside that model there are two separate parts. And so that's a really good way of conceptualizing these things, is grouping them into models, so that when you do something like duplicate that button, now you just have two buttons in your workspace, even though they have individual pieces within them. So that's cool. But for our button, we also need to rename these pieces. So the top part, I guess, can be the face, and the bottom part, I guess, will be the base. So the base won't move, but the face is what you stand on. Kind of a rhymey thing there, which is unfortunate, but there you go. So now we have two pieces that are our button here, and they look pretty good, but the user doesn't know what these buttons represent. So let's add some sort of label to them. The way that we can do that is add a billboard GUI. And now that GUI is going to be a place where we can add labels to show the user what this button does. But we will need to make it the right size. So let's say we're going to make it 5 studs wide and 2 studs tall, I guess. And you can see it there very faintly is where the billboard is, but it's a bit too low, so let's move it up by a stud. And that's not enough, so how about 2 studs? There you go, that looks pretty good. And then to that GUI, what we can do is add a text label. In fact, a couple of text labels, and we will make those the correct size. So the size, we want them to be fully on the x-axis, so 1, and then half the height on the y-axis. They're both in the same place right now, so we'll just move the bottom one so its position is on the y-axis halfway down. And now they're right next to each other. And that looks good, but let's make them look actually decent. We can change the background transparency, so that gets out of the way. Then we can change the font too. This is a pretty good one. We can change the size so that they just scale with the size of their container. And I think we will change the font color. So we will show the stroke and we'll change the color to be white. Again, you can spend more time doing this for you to make yours look better, because you'll just spend more time. So there we go. Let's take a look at that. Yep, we have a nice label here on our button. One of the things that you'll notice, though, is that the color sort of changes based on the rotation of the camera. And that's because it's sort of affected by this light source. So the light is pointing from behind, so this is in a shadow. And now the light is on the face, so it's not in shadow. Which might be useful for your theme that you're coming with, but for me, I want to turn that off. So on our billboard GUI, we can find the thing that says light influence, and we'll say our button is not influenced by light at all. But because it's not influenced by light, it's a bit darker than it should normally be, so we can sort of double the brightness and have a nice bright button no matter which way we are facing. So now let's rename these things. The first one is going to be like the title of the button, and the bottom one is going to be sort of the cost. So for the title, you can imagine it's going to show something like, okay, this is a button that buys a dropper, and the cost is going to be, $100 or whatever. So now we have a nice looking button in our Tycoon. And because it's all based under this model, if I was to duplicate this model, we've now got 2 buttons. And we didn't have to individually select each part or change those things around. So this is cool. We are ready to start our game. Yay, we can stand on this button and absolutely nothing happens, which I guess shouldn't be a surprise. So now we spend a bunch of time We've got a really nice level, we've got a place for our factory, and we've got some buttons. But until we start actually writing script, we haven't got a game, we've just got a nice looking level. So let's get into writing some script for our button. Okay, so a lot of tutorials out there would show you the easiest way to start adding script to this button, which is to choose our button here and add a new script. And there we go. We've got a button now that has a script in it. So if I was to start the game, it would print hello world. Now, this is okay. This is pretty easy to get started because if you want a reference to your button, you can just sort of say, this dot parent and go ahead and work with it in that way. The problem I find with adding scripts directly to objects like this is when I come to, design out my level by duplicating some of these buttons, I end up with a whole bunch of these scripts. And then later on, I decide, oh, that's not how my button is supposed to work. In fact, this script is all wrong and I need to change it. It shouldn't say hello world, it should say hello button. And so if I was to save it, and run that script, that's great. Now that button works, but this button, I didn't update it. This one still says hello world. So does this one. So these still have the wrong code in them. So now I'm going to have to copy this and I'm going to have to paste it in here and I'm going to have to update every single reference of my button script, even though it's spread throughout the world. So I don't like doing this because as I'm creating a game, my requirements change. I decide buttons shouldn't work like that. I decide other things should happen and I end up altering the code a lot. And I don't want to have to remember to copy and paste it into all sorts of different areas. So this isn't the way that I like to design scripted objects like this. Instead of having a script directly in the item, what I do instead is have a single script that controls all buttons. And the way that this works in Roblox is using something called the collection service. And if you've never used the collection service, it's really handy. And the way that it works is it is able to get references to things all throughout the world, as long as they are tagged correctly. So it makes heavy uses of tags. So let me show you what that looks like. If we go down to the server script service and we add our new script here, we can rename it to something like buttons, because it's going to be controlling all the buttons in our world. And instead of print hello, what we're going to do is get a reference to the collection service. So the way that that sort of works is pretty common if you've done any Lua in Roblox at all. You basically, collection service, make a local variable and make it equal to the global game object, which is sort of like a built-in Roblox thing. And it has a function on it called getService, and the name of the service that we want is the collection service. So now we have a reference to the collection service. How do we get all the buttons in our world? Well, the way that it works is the collection service has a method on it that we can call, and that method is called getTagged. And what this will do is it will search through your entire game looking for anything that has a particular tag on it. So for us, we want to be looking for the button tag. And this is going to give us a whole list of buttons that are in our game, right? So anything tagged with the word button is going to come back from this getTagged function. Now, unfortunately, we haven't yet tagged our buttons, so let's do that. For our button here, we're going to go down, we're going to go to tags, we're going to add a brand new tag. These are like little pieces of information that you can add to each individual item, and Roblox has methods that allow you to look that up, change them, add them, remove them, such as with the collection service. So now this button there has a tag. We will duplicate that button so we have two of them. And we'll call this one button 2, just so that they're slightly different. So now we've got button 1 with a tag called button, and button 2 that also has a tag called button. So if I was to run this script now, the collection service would be able to search through our game and find both of those buttons because they are both tagged with the same word button. But that's okay. We've got a list, but now we need to do something with that list. So a good way of doing that is, of course, with a for loop. And we can say for object in the pairs that are our buttons, do something. And what do we want it to do? Well, let's get it to call a function. So we'll say on added, and then whatever got added, which was this object. So up here, we'll make a new function, local function on added, and it's sending in some sort of object, and we'll say print object.name. Now, this is really cool. What's going to happen is the collection service is going to search through our world for buttons, and for each one of those buttons, it's going to call this function, which prints its name. So if I start this now, and we take a look down in the output window, you'll see that even though we only have a single script within our server script service, we've got a reference to both of those buttons. That means if we end up adding another button and then end up changing how those buttons are supposed to work, we only need to do it in this one place. So this is really compelling to me. I love using the collection service for controlling all sorts of things that are the same via tags. So if you remember, we've tagged each one of those buttons with this tag, and now the collection service can find all of those no matter where they are in our hierarchy. And this is cool. If the script loads after the buttons are already in the world, but what happens if later on we add a new button? Well, this bit of code is already going to have fired, so we won't even find out about that new button, which is a problem, but the collection service has it handled for us. So the collection service has this built-in get tagged get tagged method that we can call to give us back all of the things with that tag. But we can also listen to an event when new things with that tag get added into the world. So this is going to be very useful, and you'll see this pattern all over the place when people use the collection service. And what they do is they call collection service get instance added signal. And they pass in the name of the tag that they want to listen to. So what this really does is whenever something with this tag that you send in gets added to the world, this event will trigger. So then we need to say, okay, I'm going to connect and listen to that event. And when it happens, I want you to call my existing function on added. So this means, and this pattern is very common, that you get the collection service, you listen for new events, and you loop through all the existing ones, and all of them fire this same function. And in a similar way, not only is there an added event, but there is a removed event. So this one gets called when a new tagged object is added, and this one gets called when a new tagged object is removed, like deleted, destroyed, that kind of thing. And so we can call a new function, have removed. We can call that, copy that there. So now whenever a button comes into the world, gets added, calls this. When a button is removed from the world, it calls this one. And that's really cool. So now we've got a single script that can control all of our buttons. But we don't want to print the name of the button. That's not useful. Instead, what we want to do is when someone stands on the button, we want it to do something, right? So we need to listen to a touched event. And how can we do that on these button objects? Well, let's show you what that would look like. So we are going to get the tagged item that has the button tag, which is one of these models. We need to add a touched event, not to the model itself, but to one of these particular parts. In fact, the face part. That's the big green bit that we want to stand on, and we want to detect that when someone's standing on it. So what we can do is we can take our object and we can say dot face dot touched. So this is going to give us the touched event when someone stands on that face. And that is good. But what you'll notice here is I didn't get any sort of help with writing that. I just sort of had to remember it, that this object has a face property. So normally when you, like with the collection service, if you use a dot or a colon, you actually get some suggestions of what you can use. And I want those suggestions on my object here because I know it's always going to be a button that looks like this because I'm going to tag things that look like this and they will always have that shape. So I want help here. I don't remember how to sort of do this in my head all the time. So instead, you can sort of give Roblox the ability to help you help yourself by telling it what type this object is. Right now, it doesn't know. It's just any old object. See that error in there? It doesn't even know what kind it is. So there is a special way of telling Roblox about different types of variables. And the way that you can do this is with the type keyword. Now, you may have used this before and you may not. So this is really useful to me and I use it all the time, is typing these things. So let's create a new type for our button. We'll call it button model. And we will say that our button model type is a model, just to start with. So now we can do a colon here and say button model. And now within this function, wherever I use the word object, Roblox is going to know that it means a button model, which in turn is just a model. So if I do dot here, I've already got all the suggestions for using object as a model. And this is really handy because now I know that, oh, my model has, the ability to get the primary part, or it has, the class name and so on and so on. And this is kind of handy, but we can do better than that because we know it's not just any generic model. It's a model that's always going to have a face, a base, and a billboard GUI. And so you can sort of extend that type with this ampersand symbol, which means combine this type model with, and something else. And so we're going to use a table of pieces, which is like these children pieces here. And we're going to say our button model is a model and it's got a face child, it's got a base child, and it's got a billboard, a GUI child. And now that's cool, but it's giving me an error because it doesn't know what face is. Face is just the name of this thing, but it doesn't know that that face is a part. So much like we told Roblox this object is a button model, we can say that this face is, by using a colon, a part. Because we know that that face is a part because we just made it. We know that base is also a part. And we know that our billboard GUI is a billboard GUI. So with this special format, we've said that we have a new type called button model, and it is equal to a model, so a regular built-in Roblox model, and it has a child called face, which is a part, base, which is a part, and billboard GUI, which is a billboard GUI. Now in here, if I go dot, you see I get extra suggestions. Not only do I get those same suggestions from the model, but now I get, oh, I have a face child that is a part. And now I'm able to get IntelliSense on those individual pieces. So now I don't have to keep in my head that object is a button that has a face and face has a touched event. The sort of editor works for me. So I really like to use these things, these typing informations, because it really helps when you have to try and remember what these formats look like, what the name of the events are, and all of that stuff. So now that it knows it's a touched event, we can see that we can listen to that touched event with a connect. And we can say, we can hook it up to a thing called on touched. And we can make a new function up here, local function on touched. And that will give us our other part, which we always know is going to be a base part. So again, we can sort of give the typing information right here to Roblox so that if we use other part inside this function, we get all these nice suggestions. So I really like using this typing information. Here, for example, we also know that this is going to be a button model, so we can do that inside there too. So now, what have we done? Well, we've got the collection service, and we've hooked up for each one of our things that is tagged as a button. we're going to call this onAdded function. And the onAdded function is going to connect to the faces touched event and listen to it. And whenever that happens, we're going to print the other part dot name so we can see what touch does. Let's see if this works. So if I start the game now and I go and stand on one of these buttons, what you'll see in the output window is I've got the name of every part that touched this button. So you see the right foot, the left foot, the lower left leg, the right leg, and so on. As I walk over it, all of these things trigger. So that's cool. My button is working and detecting something. What about this other button? Remember, we only have one copy of this script, but because we're using the collections service, it's controlling all the buttons at the same time. So you'll see, even if I duplicate these buttons, I don't have to change the script at all to have it working. So this is nice. We've got a button that detects when someone walks on it. That is really cool. Now, there is one problem with the way that this is implemented right now, is inside this touched event, we don't know what button was touched. We only know what touch does, the other part. We don't know the actual button part of this. So how do we solve that? Because right now I want to say button 1 was pressed by whatever touched us. We can't actually do that with our current code. Because this onTouched event handler only gets given the other part. We need to send in this object, which is the button that we are looking at when we add this touched event. So the way that you do this is not too bad. You can basically wrap the handler in another function, and that function can use anything within this outer scope. So what we'll do is we'll inside this connect handler, we'll have another function, and that function looks a lot like our previous onTouched. So it's going to get the other part that was, hit by this touched event. But for our onTouched thing, we don't just want the other part. We want the button, which we know is going to be a button model, so we can give it that nice type information. So now this onTouched thing isn't going to work, because if we pass in the other part, that's going to go into this part, this parameter. So instead, what we need to do is pass in the object. Now, I know this is a bit confusing, but what we've done there is inside the collection service, we're hooking up the onAdded function. So the onAdded function will get called whenever a button is added, and that is this button. So this button then hooks up the touched event on its face, and the handler for that touched event now is going to get past the other part by Roblox, whatever touched it, but we are actually going to call ourselves with not only the other part from the touched event, but the actual object that is that button. So you'll see this pattern a lot with the collection service because you need a reference to the thing that was added. Because the collection service is controlling all buttons at the same time, we have to have a way for our handlers to know which button they are talking about, or which model, or which object, or whatever you're connecting the collection service to. And so you'll see this sort of lambda wrapping function a lot, where you have a function that you want to hook up to something, but you need an extra parameter to know what was called on it. So the way that that works is we've sort of added a new function here, and we're passing in the outer object. You don't have to worry about it too much. You just have to know that now we can use that button in here to say we can say the button was touched by, and then combine it with the other part that hit us. So let's take a look at this code in action now. Now, when I stand on this button, you're going to see button was touched by right leg, lower leg, so on and so on. And if I stand on this one, it will say button 2 was touched by it. So now the code is in the same script. We just have one single script. But now this function knows which button we're talking about. And that's going to be really handy to know what each button is supposed to be doing. So I know that was a lot to take in, but you can come back to this video, watch it in slow motion, and sort of understand what's happening here. But essentially, we get the collection service, and then for each tagged button, we call onAdded. And that happens even if it is in the world already, or if it gets added later on. And when a button is detected, we're basically hooking up the touched event to the face, and we're saying call onTouched with whatever button was touched and whatever touched us. So this is cool, but there is a problem with our memory right here. Whenever we do a connect, we need to actually store that connection somewhere so that if the button goes away, we can remove that handler. So a really good way of doing this is to store this connect sort of, what is it called? RBX script connection result into some sort of table. And then whenever the button gets removed, you know that to unconnect that handler. So the way that we can do that is sort of like this. So local handler, I guess, it doesn't really matter what you call that, equals this. And then we're going to assign that into something. So let's add a new table up here called buttons. Brand new table. And we'll say buttons object, which is our actual button, equals handler. So now we have a table up there that corresponds to each button has a handler. And then if that button ever gets removed, what we can do is say buttons object dot remove. Right? Oh, sorry. It's a colon. Disconnect is the word I was looking for. So now, if the button ever gets removed, we make sure that we delete this handler because this is the handler that we stored in this object. Okay, makes sense? You don't really need it separate like this. What you can do is do that. Get rid of that line. So now you can sort of see the symmetry there. When a button gets added, we add the touch event and we store it here. And if that button is ever removed, we disconnect it here. And then the other thing is we might as well get rid of it from our table by setting it to nil. So there you go. That is a really cool collection service script. And another cool thing about this sort of collection service script is it's a nice pattern that you can use not only for buttons, but for other things in your game. And when you've got a pattern that you commonly use, it is so good because you can just reuse that code without having to write everything from scratch. So you'll see us do that later on in the video. But for now, there you go. We have a working button. At least it detects when someone stood on this button, and it detects when someone is stood on this button from that singular script. Now, they don't do anything yet, so maybe we should work on that next time. So that's it for this video. If you enjoyed it, like and subscribe, leave a comment, ring that notification bell, all that good stuff, and I will see you next time.